In this video we're going to look at solving problems to do with the gradients of curves. So this first question, we're just looking to find the gradient of the curve y equals 2x squared minus 3 at the specific point where x is equal to 4. So the first thing I'm going to do is I'm going to find an expression for the gradient of the curve, and I'm going to do that through differentiation. So I'm going to find dy by dx, and so I'm going to differentiate the first term, so I multiply by the power and reduce the power by 1, and when I differentiate, number of terms will disappear. So 4x is the gradient of the curve y, in this case, or y equals 2x squared minus 3 I should say. And I want to find it at the specific point where x equals 4. So at x equals 4, dy by dx is equal to 4 lots of 4. So I'm just substituting in my value for x. So I get 16. So the gradient of this curve at the point where x equals 4 is 16. In this second question, I'm going to look at doing exactly the same thing, just looking at using the function form rather than the y equals form. And that doesn't really change what we're trying to do, but it does change the way in which we need to notate it. So the first thing I'm going to do is I'm going to differentiate, so I'm going to find f dash x. So I multiply by the power, reduce the power by 1, multiply by the power, reduce the power by 1 again. So this is my gradient function, or my derived function. And this will be an expression for the gradient at any point on the curve, but I want to know specifically at the point where x equals 1. And when I notate this in function form, then I'm substituting in a value of 1, so I am now looking for f dash 1. And then I can substitute in my values. And now I can evaluate that. So 1 to the 4 is just 1. So I'm left with 5 over 3. And then 1 squared is just 1. So 5 over 3 subtract 6. So I'm going to write that as 5 over 3 subtract 18 over 3. So I can do that subtraction, and I'm going to get negative 13 over 3, which is my gradient at the point where x equals 1. This final example, a lot longer question here. So we're asked to find the x coordinates of the points where the curve y equals a third x cubed minus a half x squared minus 6x has a gradient of 0. So we're looking at the gradients, so I'm going to find an expression for the gradient to start with, so dy by dx. So multiplied by the power, so a third times 3 is just 1, reduce the power by 1, multiplied by the power, so negative a half multiplied by 2 is negative 1, so it just gives me negative x. And then when we've got a term with just an x in it, then the x disappears and we just are left with the coefficient, so subtract 6. And it tells us that this curve has a gradient of 0 and we want to find those points. So dy by dx is the gradient, so 0 is equal to x squared, subtract x, subtract 6, and I've got a quadratic to solve, so 0 is going to be x subtract 3 and x add 2. So from this first bracket I will get x minus 3 equals 0, and from my second bracket I will get x plus 2 equals 0, and then solving that gives me x is equal to 3 and x is equal to negative 2. So there are 2 points on this graph or on this curve where the gradient is 0, and they occur at x coordinate 3 and x coordinate negative 2. If I wanted to go and find the y coordinates as well, I could substitute those back into the original function.